Watching a video, just go through the calculations. So first thing to do was to calculate the total impedance. So we work on that to get the total impedance in rectangular form, 1513 plus 115 j ohms, and then put that in polar form for our future calculations, 1517 at angle 4.34 degrees. That will allow us then to calculate the primary current, which is also the secondary current reflected to the primary side. We do that by dividing the primary voltage by the total impedance just calculated. We end up with a primary current and a reflected secondary current of 264 milliamps at an angle of minus 4.34 degrees. The next stage is to reflect that secondary reflected secondary current, transfer it back to the secondary side. So our secondary current reflected is I2 over A, so we rearrange that to I2 is equal to A times I2 dash, and we come up with a secondary current of 422 milliamps at angle minus 4.34 degrees. There's then two ways to tackle the secondary voltage. The simplest way, now we've got a secondary current, is simply to multiply that secondary current by the original load of 546 ohms. That gives us a secondary terminal voltage of 230 volts. Note that the angle is the same as the current. That's because the load is purely resistive. Over here, the alternative method is to calculate what the secondary terminal voltage is reflected to the primary side. We get 369 volts at angle minus 4.34 degrees. We then go through a process of transferring that back to the secondary side by dividing by A, and we get 231 angle minus 4.34. The slight difference between the two can be attributed to some rounding errors in the conversion process and so on. So that's a useful check if you've got time in the exam, is to just quickly do the opposite method and check you get the same answer with both. And then, because this load is purely resistive, we know that our voltage and current are in phase with each other. We can therefore ignore the phase angles when calculating the secondary power. So we just do the 422 milliamps multiplied by the calculated secondary voltage, and we get a power output of 97 watts. So we'll just transfer these calculated results into here. We won't worry about the angles. We'll just record what the magnitudes are. So primary current was 200 and something. Primary current. 264 milliamps. The secondary current secondary voltage 230, wasn't it? Yeah. And the power output was 97 watts, wasn't it? Okay, so we'll pause the video there, and we go and run the transformer up with the 546 ohm load and see what we get and see if that concurs with those results. So for the benefit of our video this week, let's just put our measured values on. What did we get for primary current measured? 274 milliamps. Secondary current 426 milliamps. Secondary voltage 231 volts, and power output 98 watts. Yep. So there's no significant difference between the calculated values from the model and the actual values measured in real life. We'll just put a title to this. That's the rig transformer loaded with 546 ohms nominally. Yep. So we'll call that a day this week, right? And like I said, if and this goes out to those watching the video too, I'd recommend you have a good. The plan is to have a good look through the stuff we've covered early doors this week, and email with me with where you want to start with revision next week. Okay, I'm going to try and get the online stuff up as early as possible at the latest Friday morning, so that those not here today can catch up. And we've got 2 heavy weeks of revision coming up in time for the exam in January.